This is SpaceTime, Series 29, Episode 5, for broadcast on the 12th of January 2026. Coming up on SpaceTime, evidence that mysterious substance known as dark matter might be able to interact with neutrinos. A serious medical issue forces one of the crews aboard the International Space Station to return home early. And did you know that studies have confirmed that galaxies spin like clockwork? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists may be a step closer to solving one of the universe's great mysteries, with new evidence that dark matter and neutrinos might be capable of interacting. A discovery that, if proven correct, will offer a rare window into the darkest recesses of the cosmos. The new findings, reported in the journal Nature Astronomy, are challenging science's understanding of the standard model of particle physics, the foundation stone of our understanding of the universe. Dark matter and neutrinos are two of the least understood components that make up our universe. Dark matter is a mysterious invisible substance that makes up around 85% of all the matter in the universe. But it doesn't interact with normal matter except through gravity. So scientists really have no idea what it is. They only know it exists because they can see its gravitational influence on regular matter, holding galaxies together as they rotate and bending light from distant background objects through a process called gravitational lensing. Neutrinos are the most common substances in the universe. They're tiny subatomic particles produced in places like the cores of stars, in supernova explosions, and in nuclear reactors. But they're extremely weakly interacting with all other matter. In fact, right now there are billions of them passing through you, and you have no idea that it's happening. There are three known types or flavors of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos, each with different masses. What makes them even more unusual is that they oscillate between these three flavors. So, an electron neutrino generated in the core of, say, the Sun might end up as a muon or tau neutrino by the time it reaches the detector here on Earth. The standard model of cosmology, known as lambda cold dark matter, with its origins in Albert Einstein's general theory of relativity, proposes that dark matter and neutrinos exist independently and do not interact with each other. And that's where this new study comes in. It's questioning that hypothesis, challenging the long-standard cosmological model. The authors think that they've detected signs that these elusive cosmic components may interact, offering a rare glimpse into those parts of the universe we can't see or easily detect. By combining data from different eras, scientists have found what they believe is evidence of interactions between dark matter and neutrinos that could have affected the way cosmic structures such as galaxies are formed over time. The data spans the history of the universe. It includes observations of the early universe using the highly sensitive ground-based Atacama Cosmology Telescope and the European Space Agency's Planck spacecraft. Both instruments are specifically designed to study the faint afterglow of the Big Bang 13.8 billion years ago. Then there's the late universe data. It comes from a massive catalogue of astronomical observations taken by the Dark Energy Camera on the Victor M. Blanco telescope in Chile, along with galaxy maps from the Sloan Digital All-Sky Survey. One of the study's authors, Eleonora Di Valentino from the University of Sheffield, says the better science understands dark matter, the more insight it can gain into how the universe evolves and how different components are connected. These new results address a long-standing puzzle in cosmology. See, measurements of the early universe predict that cosmic structures should have grown more strongly over time than what we actually observe today. However, observations of the modern universe indicate that matter is slightly less clumped than expected, and that's pointing to a mild mismatch between early and late time measurements. Now, this tension doesn't mean the standard cosmological model's wrong, but it may suggest that it's incomplete. The study shows that interactions between dark matter and neutrinos could help explain this difference, offering new insights into how structure formed in the universe. The findings set a clear path for future testing of the theory, using more precise data from future telescopes, cosmic microwave background radiation experiments, and weak lensing surveys, which use the subtle distortion of light from distant galaxies to map the distribution of mass throughout the universe. If this interaction between dark matter and neutrinos is confirmed, it would be a fundamental breakthrough. It would not only shed new light on a persistent mismatch between different cosmology probes, but also provide particle physicists with a concrete direction, indicating which properties to look for in laboratory experiments in order to help finally unmask the true nature of dark matter. This is SpaceTime. Still to come, a serious medical issue forcing space station crew to return home early. And did you know that studies have confirmed that galaxies spin like clockwork? All that and more still to come on SpaceTime. NASA's SpaceX Crew 11 aboard the International Space Station are returning to Earth early due to medical concerns for one of the astronauts aboard the orbiting outpost. Last week, NASA abruptly cancelled an extravehicular activity, or EVA, that's NASA speak for spacewalk, due to what the agency described as a sudden medical concern. Now, they've given few details citing patient confidentiality, but they did confirm the medical issue wasn't related to space operations and it wasn't an injury. NASA Administrator Jared Isaacman says the medical issue isn't an emergency that requires immediate return to Earth, but it does require a more comprehensive examination than what can be accomplished in orbit. Therefore, the difficult decision was made to send Crew 11 back home early. And it's quite an historic decision. It's the first time in 26 years of space station operations that medical issues have been serious enough to force a crew to return early.
For over 60 years, NASA has set the standard for safety and security in crewed spaceflight. In these endeavors, including the 25 years of continuous human presence on board the International Space Station, the health and the well-being of our astronauts is always and will be our highest priority. Yesterday, January 7th, a single crew member on board the station experienced a medical situation and is now stable. After discussions with Chief Health and Medical Officer Dr. J.D. Polk and leadership across the agency, I've come to the decision that it's in the best interest of our astronauts to return Crew 11 ahead of their planned departure. Within the coming days, the Dragon Endeavour spacecraft will depart the International Space Station with Commander Zena Cardman, pilot Mike Fink, Kimya Yui from JAXA, and Oleg Platonov of Roscosmos, and safely return them to Earth. We expect to provide a further update within the next 48 hours as to the anticipated undock and reentry timeline. Over the last 5 months, Crew 11 contributed to the ongoing operations of the space station, conducted extensive scientific research, completed the majority of their mission objectives, and upheld the standards of professionalism for which astronauts are known. Crew 12 is currently scheduled to launch as soon as mid-February. Alongside our international and commercial partners, NASA is evaluating their timeline to include earlier launch opportunities. We will provide more information when it's available. In the meantime, NASA astronaut Chris Williams, having launched to the station on November 27th on Soyuz MS-28, maintains our American presence in space and will support the space station's operations and scientific efforts. NASA astronauts and our teams in mission control and our professionals who train for every possible scenario at every step of the mission, including moments just like this. I'm proud of the swift effort across the agency thus far to ensure the safety of our astronauts, and I know NASA and our commercial partners will successfully bring Crew 11 safely home. And with that, I'll turn it over to Associate Administrator Amit Kshatriya.
Good evening. Thank you, sir. I'll be brief. We'll get to Dr. Polk as soon as we can, but I'll just add a few comments. In every discussion over the last 24 hours as we've assessed the situation, crew safety has always remained our highest priority, and as it always is across the agency. We never take shortcuts. We never compromise when it comes to protecting our astronauts. The work accomplished during this period reflects the precision and professionalism of the flight control teams on the ground and the astronauts aboard ISS. Our crews are extensively trained, as the administrator mentioned, to manage unexpected medical situations and other off-nominal events, including onboard training, which we conduct regularly for these situations. Yesterday was a textbook example of that training in action. Once the situation on the station stabilized, careful deliberations led us to the decision to return Crew 11, as the administrator mentioned, while ensuring minimal operational impact to ongoing work aboard ISS. Operating ISS is a complicated task and has been for the past 25 years with crews on board. The safe operation of the station and the protection of the crew, who are the stewards of station operations, is the hallmark of flight operations and what we are reminded of every day of the unforgiving nature of human spaceflight. With that, I'd like to hand over to Dr. Pope.
Thanks, Amit. First, probably goes without saying, but I'll still reiterate as a physician that I'm not going to speak about any particular astronaut or any particular specific diagnoses. I'd ask that we still respect the privacy of the astronaut. As administrator mentioned earlier, the astronaut is absolutely stable, so I have to reiterate that again. But anytime we have a medical incident, we embark on looking at diagnoses and what we would call a workup to get a differential diagnosis on what's happening with that patient or astronaut on board. And as many of you know, we have a very robust suite of medical hardware on board the International Space Station, but we don't have the complete amount of hardware that I would have in the emergency department, for example, to complete a workup of a patient. And in this particular incident, that the medical incident was sufficient enough that we were concerned about the astronaut, that we would like to complete that workup. And the best way to complete that workup is on the ground, where we have the full suite of medical testing hardware. Now, again, because the astronaut is absolutely stable, this is not an emergent evacuation. We're not immediately disembarking and getting the astronaut down. But it leaves that lingering risk and lingering question as to what that diagnosis is, and that means there's some lingering risk for that astronaut on board. And so always we err on the side of the astronaut's health and welfare, and in this particular case we are doing the same. And I should reiterate, in our 25-year history of the International Space Station, we've had many models and Monte Carlo analysis models that have said we should have had a medical evacuation approximately every 3 years in that 25-year history, and we've not had one to date. And even in this case, we're erring on the side of caution. Again, it's not an emergent evacuation, but we are erring on the side of caution for the crew member and in their best interest and in their best medical welfare.
And there we heard from NASA Administrator Jared Isaacman, Associate Administrator Amit Raya, and NASA Chief Health and Medical Officer Dr. J.D. Polk. Past medical problems on station have ranged from space sickness and skin rashes through to stomach upsets and most things in between, but none was serious enough to force a medical evacuation. Of course, the space station does maintain a large range of first aid equipment, including a backboard and specialised methods for performing CPR in microgravity. There's also a range of over-the-counter medicines kept in stock, including things like aspirin. Crew 11 launched to the space station aboard a Dragon SpaceX capsule on a Falcon 9 rocket from the Cape Canaveral Space Force base in Florida last August for what was slated to be a 6-month mission. They were scheduled to return to Earth next month after being replaced by Crew 12. The existing 3-man Soyuz MS-28 crew will remain on station in the meantime. This is Space Time. Still to come. Did you know that studies have confirmed that galaxies rotate about once every billion years, no matter how big they are? And later in the science report, a new study has shown how food preservatives are linked to a higher risk of cancer. All that and more still to come on Space Time. Did you know that it's been shown that galaxies all rotate about once every billion years, no matter how big they are? The findings, reported in the monthly notices of the Royal Astronomical Society, were based on observations of galaxy density, the amount of mass galaxies contained for a given area. Planet Earth spinning around on its axis gives us the length of the day, and a complete orbit of Earth around the Sun takes 1 Earth year. Our solar system takes 230 million Earth years to complete one orbit around the centre of the Milky Way galaxy. That makes our solar system somewhere between 16 and 20 galactic years old. The study's lead author, Gerhard Muir from the University of Western Australia node of the International Centre for Radio Astronomy Research, says it's not Swiss watch precision, but regardless of whether a galaxy is very big or very small, if you could sit on the extreme edge of its galactic disk as it spins, it would take you around 1 billion years to go all the way around. Muir and colleagues were able to calculate that all galaxies of the same size have the same average density. He says discovering such regularity in galaxies provides astronomers with a better understanding of the mechanics that make them tick. While a dense galaxy will rotate at a set speed, another with the same size but lower density will revolve more slowly. The authors also found evidence of older stars existing out to the very edges of galaxies. Muir says that based on existing models, he expected to find a population of young stars at the very edge of the galactic disks he studied. But instead of finding just gas and newly formed stars at the outer edges of their disks, Muir and colleagues also found a significant population of older stars, along with a thin smattering of younger stars and interstellar gas. He says it's an important result, because knowing where a galaxy ends means astronomers can limit their observations and not waste time, effort or computer processing power on studying data beyond that point. So, because of this work, scientists could determine that galaxies rotate once every billion years with a sharp edge that's populated with a mixture of interstellar gas and both young and old stars. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has shown how food preservatives are linked to a higher risk of cancer. The findings, reported in the British Medical Journal, looked at the diets of over 105,000 patients. The authors calculated participants' intake of different preservatives using detailed 24-hour dietary records filled out regularly over several years. They then tracked the participants' health, looking specifically for a diagnosis of cancer over a period of 14 years from the start of the survey in 2009. Of the 17 preservatives they analysed, higher intakes of 6 showed some link with cancers. And while the study doesn't prove that eating more of these additives causes a higher cancer risk, the authors say these preservatives do appear to affect your immune and inflammatory systems. Scientists say that some 1.8 million people every year are dying of heart-related problems because of heat or cold. The findings, reported in the Journal of the American College of Cardiology, used data on heart deaths as well as temperature data from 32 countries to estimate how many heart-related deaths are linked to cold and hot weather. Looking at the years 2000 through to 2019, the authors found that cold-related deaths accounted for 8.2% of all heart deaths, while heat-related deaths were less common, accounting for about 0.66% of all heart deaths. The authors found an overall decline in temperature related to heart deaths due to a reduction in cold-related deaths. However, heat-related deaths increased over that time. Meanwhile, a separate study in the same journal has shown that man-made pollutants and climate change contribute to millions of deaths from cardiovascular disease every year. The authors found that pollution in all its forms is a greater heart health threat than war, terrorism, malaria, HIV, tuberculosis, drug use, and alcohol consumption all combined. The report focused on global warming, as well as air pollution and exposure to wildfire smoke, and highlights the lesser-known drivers of heart disease, including soil, noise and air pollution, and exposure to toxic chemicals. A new study has shown that some of the very earliest animals to have lived, such as jellyfish and sea anemones, appear to have similar sleeping habits to humans. The findings, reported in the journal Nature Communications, examine the sleeping patterns of nematode stella vectensis sea anemones in the lab and Cassiopeia andromeda jellyfish in both the lab and in their natural habitat. The authors found that both appeared to sleep for about a third of the day, just like humans do. Looking into how sleep works in these two creatures, the authors found that it appears to be driven by an internal sleep drive, as well as light in the case of the jellyfish, and an internal body clock for the anemone. For both, sleep appeared to play a role in reducing DNA damage, supporting the theory that sleep originally evolved in animals to protect against DNA damage in a wide range of species. Climate change deniers have been accused of cherry-picking after reports on social media claim that Arctic sea ice coverage has been increasing in recent years. Satellite data from the European Space Agency's Copernicus program, which runs the Sentinel satellites, shows the Arctic sea ice sheet is losing mass overall. And year-to-year fluctuations cannot be seen as a sign of rebound or reversal of this long-term trend. Although the total mass of ice in Antarctica has fluctuated since 2020, this followed almost 20 years of continuous decline, in which the continent lost some 2.5 trillion tonnes of ice. The total mass has significantly decreased since 1979, with the biggest losses occurring in the late 1980s. A temporary growth in ice mass, reported in the journal Climate and Atmospheric Science, showed Antarctica gained 205 billion tonnes of ice in 2022 due to increased snowfall, corresponding to record lows in the sea ice extent. But the skeptic's Tim Mendham points out that this gain was reversed the following year.
The story here is about choosing your moment to look at the measurements. And the mass of ice on Antarctica, it does fluctuate. It fluctuates with various weather things. A few years ago, there was supposed to be anomalous snowfalls thanks to a El Nino or La Nina effect, which was sort of an unusually long one. And that increased the amount of ice or snow turning into ice in especially East Antarctica. And I keep trying to figure out which is East Antarctica. How do you measure east as opposed to west? Anyway, east is the big bit, and west is the bit where there's sort of less ice. And in those places where there's less ice, and it's not as thick, and there are various sort of water temperature issues, they lost ice dramatically. But the east bit increased snow and ice over a period of about 2022, 2023, that sort of thing. But in the few years before, they lost so many billions of tons of ice, and then in that short period, it actually had a bit of an increase, and then since then, it's also gone down again. So it's just being selective, looking at the fluctuations.
So they're cherry-picking the data
very
they
much,
want.
Yeah, cherry-picking, exactly. And it goes up and down, but the overall effect is going down. There might be sort of moments where it goes up, but overall it's going down. Between April 23 and January 24, it lost about 600 billion tonnes. Shortly after that, it had an increase, and then it's lost it again. So the increase has been wiped out. Any increase has been wiped out by the continual melting of the ice, especially in the western Antarctic. That's getting very bad, and that's going to increase. And the eastern, because of the thicker level of ice, is slower to melt, and therefore any sort of report you see of Antarctic ice increasing, look at it over a decent period of time. And over a long period of time, I think they're talking about over the last 23 years, it's 135 billion tonnes a year is being lost. So when you talk about a few 100 million tonnes of increase in a year or two because of heavy snowfall, that's totally wiped out every year. So it goes up a little bit and then down a lot and up a little bit. Yes, it's any figures you see to show that the Antarctic ice is increasing is cherry picking.
That's the skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.